Today we are going to be working on solving systems by substitution day 4, part 2. Our content objective is students will be able to solve a system of two equations by the substitution method. Our language objective is students will be able to discuss ways of checking if the solution you derived is truly a solution. And why am I learning this? Well, it's important for real-world problems like finding the best value among high-speed internet providers. So first, we're going to go ahead and jump into our first example. Hopefully from yesterday's lesson, you kind of got an idea of what we were trying to do. In a case like this new method that we're trying to learn is to make sure that our both equations has a variable that's already solved for. So in this case, since this one's already solved for y, I'm going to go ahead and make sure both equations are solved for y. So the first one is y equals x plus 5. The second one here is not solved for y, so I'm going to have to manipulate it a little bit first before we get started. So 2x plus y equals 8. Since this one's y equals, I would like to do the same for this equation. I'm going to isolate y by first subtracting 2x from both sides, which leaves me with y equals negative 2x plus 8. At this point, what you're going to do is go ahead and take this value, x plus 5, and since that's the value for y, I'm going to go ahead and substitute in for y. And again, I substitute in for y because here it says y equals. So now I'm going to be left with x plus 5 equals negative 2x plus 8. So you're going to notice here that we do have variables on both sides. Normally what we do in that case is we move it over to the left. Does it always have to be moved to the left? The answer is no, but we normally do that because we prefer the variable to be on the left. So here I'm going to go ahead and add 2x to both sides, which leaves me with 3x plus 5 equals, this is going to go away because it's 0, equals 8. Now we're going to get rid of our constant by subtracting 5, leaving me with 3x equals 3. Now, this does mean 3 times x, so the inverse would be to divide both sides by 3, therefore leaving me with x equals 1. But I'm not done yet. I need to go ahead and substitute this back into another original equation. Let's plug it in for x. So now we have here y equals, instead of x, let's go ahead and substitute our 1 plus 5. So I'm going to be left with y equals 6. So now, since I have both x and y, I can go ahead and say that I think the solution is 1, 6. And again, you know that I always say I think at first because I'm not sure until I have checked my answer. So let's go ahead and check the answer. Here, just a friendly reminder that x is 1 and y is 6. I'm going to go ahead and plug in my values here. 6 equals 1 plus 5. This is true, so it works for the first equation. I'm going to check the second equation. 2 times x, which is 1, plus y, which is 6. Does it equal 8? Let's see. 2 times 1 is 2, plus 6. Does this equal 8? Yes, this is true. And because it works for both equations, I can confidently say that the solution to this system is indeed 1, 6. So at this point, what I'm going to have you do is go ahead and try number 2 on your own. Go ahead and pause the video and see how well you do. Okay, so let's check our answers. Hopefully you saw here, since this one's already solved for y, you're just going to write that down. And then I'm going to go ahead and change this equation so it's also solved for y since it's not already solved for y. So here we have x minus y equals 4. In order to solve for y, you're going to have to first get rid of x, which is going to leave me with negative y equals negative x plus 4. Y is not solved for just yet. We're going to get rid of that negative 1. So that's going to leave me with, let's see, a positive y equals a positive x minus 4. So now both y's are solved for in each equation. So I'm going to go ahead and take this expression here and substitute it in for y. So now I'm going to be left with 2 minus x equals x minus 4. So you're going to go ahead and first get rid of the, not get rid of the x, but move the x over to the left by subtracting x to both sides, leaving me with 2 minus 2x, this goes away, equals negative 4. Now we're going to move our constant over to the right, so I'm going to subtract 2 to both sides, leaving me with negative 2x equals negative 6. This means negative 2 times x, so the inverse would be to divide both sides by a negative 2. So here the negatives cancel out, so I'm left with x equals 3. Now, since I know the value of x, I'm going to go ahead and take this value and plug it in for x. So now I'm going to be left with y equals 2 minus 3. It gives me y equals negative 1. Now that I know both, I'm going to go ahead and say that I think the solution is 3 comma negative 1. And again, I say I think because I have yet to check my answer. So let's go ahead and check it real quick. In this case, the x's are 3's and the y's are negative 1. So here we have negative 1 equals 2 minus 3. Is this true? Yes, so it works for the first one, but again, for this system to have the solution of 3 comma negative 1, it must work for the second one as well. So 3 minus negative 1 equals 4. Here we have 3, and negative times a negative is a positive 1. This is also true. So I can confidently say that the solution to this system is indeed 3 comma negative 1. So hopefully that's the answer that you got as well. Okay, so now moving into a slightly more difficult problem. Here, I have x that's solved for, so I'm going to go ahead and write that down first. X equals 3y. In the second one, I don't have the equation solved for x, so I'm going to have to change it a bit. So we have 2y minus 4x equals 5. Since I'm trying to isolate x, what I'm going to do first is get rid of the 2y. So I'm going to subtract 2y from both sides, leaving me with negative 4x equals negative 2y plus 5. But we still have one more step. We're going to have to get rid of this negative 4 by dividing both sides by negative 4. Notice on this side I divide each term by negative 4 just to save myself some time, leaving me with x equals, well, the negatives cancel each other out. 2/4 do reduce to 1/2. Y, positive time divided by negative, is a negative 5/4. So I know what you're thinking. We have a fraction. And that's okay. It's not the end of the world. We know how to work with fractions to just take it one step at a time. So now, since both variables are solved for, we're going to go ahead and substitute it in. And just a quick reminder, some of you might be wondering why we're doing this. This is just another method that I want you to have in your toolbox when we're solving systems. In a case like this, when variables are solved for, the same variable is solved for in each equation, what's nice about it is you don't have to worry about distributing that much or combining like terms. So if you like this method, definitely use it. So here, I'm going to go ahead and take this 3y and substitute it in for x, yx, because here it says x equals, so I'm plugging in for x, leaving me with 3y equals 1/2 y minus 5/4. So again, since we have variables on both sides, I'm going to go ahead and move it over to the left. I'm going to subtract 1/2 y from both sides. Now here's what I would suggest. Some of you can do this in your head. What's 3 minus 1/2? 2.5. But if you can't do that, you can, of course, simply do some side work. So let's practice that. 3 is basically written as 3 over 1 minus 1/2. Our lowest common denominator is going to be a 2. So here, multiplying by 2, we're going to be left with 6 minus here. This one's not going to change, so it's going to be minus 1. So you're left with 5/2. But again, if you could do it in your head, 3 minus 1/2 is basically 2.5. You can convert this into an improper fraction, and it would still be 5/2. So now I have 5/2 y equals negative 5/4. So you notice I've been doing this here. 5/2 y means 5/2 times y. So this is going to be helpful for you to understand, oh look, it's just multiplication, so the inverse of that would be to divide both sides by 5/2. So this is going to cancel out, leaving me with y equals a negative. Let's do 5/4 divided by 5/2, which essentially is 5/4 times 2/5. You're going to notice here the 5's cancel each other out. Here you can divide both by 2. 2 divided by 2 is 1. 4 divided by 2 is 2, which leaves us with 1/2. So our answer is y equals negative 1/2. But we're not done. We still need to figure out what x is. So you're going to take this value and substitute it in for y. So x equals 3. I like to write it as a fraction since I am multiplying by another fraction. So I just put it over 1. So I'm going to say that x equals a negative 3/2. So now that I have both, I can go ahead and say I think the solution is negative 3/2, comma, negative 1/2. So notice here, yes, there was fractions, but I was able to survive. I just took it one step at a time, and I got an answer. But you notice I said I think the answer is negative 3/2, comma, 1/2, because of course I still need to check my work. So let's go ahead and try that out here. If we check our work, it's reminding ourselves, hey, x is our negative 3/2 and y is our negative 1/2. So you'll notice here we traditionally put the negative in the numerator. Does that always have to be the case? No, it's just easier for us instead of writing it like this, okay? Because a lot of students will ask, is it negative for the 3 or for the 2? You just have to pick one. It's either for the numerator or just for the denominator. Okay, so on that note, let's go ahead and substitute our values in. X is going to be our negative 3/2 equals 3. Again, since we're working with fractions, let's make 3 into a fraction and multiply by y, which is negative 1/2. And I'm just going to check my work. This is going to stay negative 3/2. Here, positive times a negative is a negative. 3 times 1 is 3. 1 times 2 is 2. This one checks out. Next one, 2. Again, since I'm multiplying by a fraction, let's write it as a fraction. Y is going to be negative 1/2 minus 4 over 1 times x, which is negative 3/2, equals 5. So here, you're going to notice the 2's cancel each other out, leaving me with just a negative 1. Here, let's just decide right now so we can take care of the signs. A negative times a negative is a positive. Now I don't have to worry about the signs. 2 divided by 2 and 4 can be reduced. 2 divided by 2 becomes a 1. 4 divided by 2 becomes 2, so I'm left with a 6. And again, because I already took care of the sign, I said negative divided by negative, negative times a negative is a positive. I didn't have to worry. So this is going to equal 5. Negative 1 plus 6 is a 5. 5 equals 5. So this checks out. So since it works for both, I can confidently say that the solution to this system is going to be negative 3/2, comma, negative 1/2. Okay, so now what I would like you to do is go ahead and try number 4. Number 4 is just a little bit more challenging than the last few, so go ahead and give it a shot. Okay, so let's see how well we did. For number 4, you're going to notice none of the variables are solved for, so you're going to have to work with this here. So for the very first one, I have my eye on x. I have a good idea that probably the best bet would be to isolate x. So let's first do that. 2y plus x equals 5. So first, subtract 2y from both sides, leaving me with x equals negative 2y plus 5. So now that I've isolated one of my variables to solve for x, I'm going to go ahead and manipulate the next one. So here we have 2x plus 3y equals 7. In order to solve for the x, I'm going to first get rid of the 3y by subtracting it, which leaves me with 2x equals negative 3y plus 7. Now here, in order to isolate x, I still need to get rid of this 2 by dividing both sides by 2. So this is divided by 2. Now on this side, it's going to be easier if you divide each term by 2. It saves you that extra step. So now I have x equals a negative 3 halves y plus 7 halves. And again, we have fractions, but it's not the end of the world. We're going to take it step by step and see where it takes us. So, since both of these are solved for x, I can go ahead and take this expression for x and substitute it in for x. So now this is going to leave me with a negative 2y plus 5, which equals the negative 3 halves y plus 7 halves. So in this case, since we have variables on both sides, just a real quick reminder, this method's really nice because you're going to notice I didn't have to distribute nor combine like terms here. So just keep that in mind. Here I'm going to add 3 halves y to this side and add 3 halves y to this side as well. So I'm going to have to do some side work, so just cutting up my paper. We have negative 2 over 1 plus 3 halves. Our lowest common denominator is going to be a 2. I'm going to have to change this by multiplying it by 2, multiplying by 2, so that's going to be negative 4. Plus, this is going to not change at all, so it's still going to be plus 3, which leaves us with a negative 1 half. So here we have a negative 1 half y plus 5 equals 7 halves. Now we're going to have to move our constant over. So I'm going to go ahead and subtract 5 from both sides, which leaves me with a negative 1 half y. Whoops, just kidding. Let's do the side work real quick. We have 7 halves minus 5 over 1. Here, our lowest common denominator is going to be a 2. This one's not going to change at all, so we're just going to leave it as a 7. However, this one here is going to change by 2, so that's minus 10, which leaves us with negative 3 halves. Okay, so notice none of the actual fraction work wasn't too complicated. So going back here, I'm left with negative 1 half y equals a negative 3 halves. Last but not least, we're going to get rid of this coefficient. This means negative 1 half times w, so the inverse would be to divide by that negative 1 half. This is going to go away, leaving me with y equals, here the negatives cancel out. Let me just divide real quick off to the side. 3 halves divided by 1 half is equivalent to 3 halves times 2 over 1. The 2's cancel each other out, leaving me with 3. So here it worked out nicely, y equals 3. I'm going to go ahead and substitute this back in for y. So here we have x equals negative 2 times 3 plus 5. Here x equals negative 6 plus 5, so I'm going to say that x equals negative 1. So at this point I have what x equals, I have what y equals, so I'm going to say that I think the answer is negative 1 comma 3. But again, I'm saying that I think the answer is this because I still need to check my work. So let's go ahead and quickly do that. Just a friendly reminder. In this case, we're going to say that x is negative 1 and y is 3. So we have 2 times 3 plus a negative 1 is supposed to equal 5 Is this true? Well, let's see. 6 minus 1 is definitely 5, so this one checks out. Here we have 2 times negative 1 plus 3 times 3 equals 7. Here we have a negative 2 plus 9 equals 7. This is also true. Since it works for both equations, I'm going to say the solution to this system is indeed negative 1 comma 3. So now I know what some of you are thinking. You're probably asking, why would I go through the trouble of making that into a fraction? Why not instead learn what we did in a previous lesson and just isolate one of the variables and substitute it back in? You're totally right. But again, I'm just trying to get you to feel comfortable with using different methods so that you can utilize it whenever you think is best fits the equation you're given. So let's go ahead and try that. Let's practice what we learned from the previous day. So here what we did in the past was we looked for an equation that had a variable that was already solved for, and if we didn't, we changed one of them. So in this case, let's change this one to solve for x, since that's going to be the easiest one to work with. That won't leave us with a fractions. Whenever you have a coefficient of 1, you're not going to end up with a fraction. So here, isolating x, you first subtract 2y from both sides. So you're left with x equals negative 2y plus 5. So now that you have a variable that's already solved for, you can just simply plug it into the next one. So for this one, you're going to write 2x plus 3y equals 7. So what we did in the previous day, we didn't have to have both variables solved for each equation. All we did was make sure we had one. We took the expression and substituted in. In this case, we substituted in for x because it's x equals. So you're going to do 2 times the quantity, negative 2y plus 5 plus 3y equals 7. So this is exactly what I was trying to remind you. In this case, when we're substituting, you're going to notice that you are going to have to distribute and you are going to have to combine like terms. So you just got to be very careful with that. So here you're going to be left with negative 4y plus 10 plus 3y equals 7. We're going to combine like terms. So negative y plus 10 equals 7. Subtract 10 from both sides. We have negative y equals negative 3. Last step, divide that coefficient. The negatives cancel each other out. Y equals 3. So notice y is still 3, just like in the last one. But now you're going to go ahead and substitute it in for y. So x equals negative 2 times 3 plus 5. So we have x equals negative 6 plus 5. So x equals negative 1. So notice here your solution is exactly the same. It really didn't matter which method you chose, but again, the whole point of these past couple lessons was to have you understand that there's different ways of solving it, even different types of substitution, and I want you to know how to do any of the types. So of course we already checked this one, so there's no point in checking it again. So now for the big kahuna, let's try number 5. What I'm going to have you do is go ahead and pause the video and choose whatever method you'd like to solve for number 5. Okay, so let's see how you did. Okay, for this particular problem, what I would choose to do is go ahead and solve for one of the variables. Okay, actually, let's just go ahead and do what we've been doing, which is make sure we have both equations solved for the same exact variable. Okay, so for the first one, let's say we would like to solve for y, just because I want to. So here we have negative 4y plus 8x equals 16. We're going to solve for y, so we're going to first subtract 8x from both sides, leaving me with negative 4y equals negative 8x plus 16. Now the next step would be to get rid of this negative 4. So we're going to go ahead and divide each term on this side, leaving me with y equals, notice the negatives cancel each other out, leaving me with 2x. Here we're going to be left with a negative 4. So for this one, let's just go ahead and practice doing it as well. We're going to solve for y. So we have 3y plus 21x equals 15. Here to solve for y, you're going to subtract 21x from both sides, leaving me with 3y equals negative 21x plus 15. Now simply divide both sides by 3, and this side we're going to divide each term by 3, leaving us with y equals negative 7x plus 5. So now, since both of them are solved for y, you can go ahead and take the expression here, substitute it in for y, because it's y equals, that's why I'm not plugging in for x. You're going to be left with 2x minus 4 equals negative 7x plus 5. Since we have variables on both sides, let's go ahead and move it over to the left. So 9x minus 4 equals 5. So again, notice the nice thing about this method would be, hey, you do not have to distribute, and you don't have to combine like terms on one side. So here, you just need to move your constant over, leaving you with 9x equals 9. Divide both sides by 9, and x equals 1. However, we're not done. We're going to have to plug that back into an original problem. So let's go ahead with this one right here. Both of them aren't that pretty. So we have negative 4y plus 8 instead of an x. Let's go ahead and plug in our 1 equals 16. So we have negative 4y plus 8 equals 16. Get rid of the constant. Negative 4y equals 8. Divide off that coefficient. And we're left with y equals negative 2. So here, I kind of ran out of space, but I can go ahead and say that I think the solution is 1 comma negative 2. But again, I'm going to say that I claim that I think it is just because I haven't checked my work yet. So let's go ahead and check our work. So now we're just going to check our work, just reminding ourselves, hey, our x's are 1s and our y's are negative 2s. So here we have negative 4 times a negative 2 plus 8 times 1 equals 16. Here, negative 4 times negative 2 is 8. Negative 8 times 1 is 8, and that's supposed to equal 16. This is true, so it definitely works for the first equation, but again, we got to make sure it works for the second one as well. So we have 3 times a y, which is negative 2, plus 21 times x, which is 1, is supposed to equal 15. So here we have negative 6 plus 21 equals 15. This is true. So it works for both. So I can confidently say that the solution to this system is indeed 1 comma negative 2. So that is going to conclude our lesson for today. Thank you so much for tuning in, and like always, until next time, bye.